Okay, in previous videos we've learned functional groups, sort of general names for classes of compounds, and now we're going to start to dig into actually naming particular compounds. So why is naming important? I think it's important for a couple reasons. One, much like science fiction books, knowing something's true name gives you some power over it, right? So if I want to look up something about a particular molecule, Google doesn't recognize structures that well, but it sure recognizes chemical names. And so if I can name something, it makes it much easier for me to get more information about it. The second thing is that naming things gives me a nice, unambiguous way to communicate about it. And by naming something, I can actually tell if it's the same or different as something else. So I can take two molecules that might look different, but if I name them and the name comes out to be the same thing, they're the same thing. Okay? So again, this is part of our communication unit. Communication in science is kind of everything. Science that can't be communicated is useless. So we need to be able to communicate to accomplish really anything. Okay, so we're going to start with alkanes. Remember, alkanes are compounds that only have carbon and hydrogen and only have sigma bonds. And so this is kind of our sort of neutral molecule, I guess, our base molecule that we'll then add stuff to later on. So these are the simple alkanes. Methane, ethane, propane, butane kind of all have old school etymologies. Once we get to pentane, hexane, heptane, octane, those are the more familiar Latin roots for numbers, right? We're used to thinking of pentagons as 5-membered rings. Hexanes, or hexagon is a 6-membered ring, right? Even in the months, right? October is the 8th month, stuff like that. Okay, so also, October is not the 8th month. There's some weird stuff going on there. Anyways, if you need some mnemonics to memorize these 8, and you should memorize these 8 names, here are some mnemonics that I came up with. You can come up with better mnemonics given 5 minutes, perhaps, but I like these. So again, I do want you to know and memorize these names. I don't think it's that hard. You certainly don't need to memorize the boiling points. So you can see that the boiling points here just monotonically increase, and that is entirely due to London dispersion forces. All of these are nonpolar. There's certainly no hydrogen bonding or anything going on like that. And so really what we have in these longer chains is just more molecule-to-molecule contact. And so that is harder to overcome with heat energy in order to boil something. Okay? Remember, boiling something means overcoming intermolecular forces. These longer chains have greater intermolecular forces than these smaller chains due to London dispersion forces. So how do we name more complex alkanes? Well, we've got a system. The first thing we're going to do, the first step, is to look at our molecule in question and find the longest carbon chain. So here, our eyes might bias us to think about this as a 6-membered chain with stuff hanging off of it. But that's not the longest chain. The longest contiguous carbon chain actually goes 1, 2, 3, 4, 5, 6, 7. Right? So the longest chain is a 7-membered ring. So the root name of this is going to be a heptane. The second step is we need to number the carbons in this longest chain in such a way to give the substituents. Substituents is just the stuff hanging off of the chain, the lower number. So what do I mean by that? So here's my 7-carbon chain. I can start here and number 1, 2, 3, 4, but then my earliest substituent comes in at carbon 4. If I number right to left, 1, 2, 3, now my first branch comes at carbon 3, and that's what I want to do. So 3 is less than 4, and so I need to number these 1, 2, 3, 4, 5, 6, 7. Our next step is to name our substituents. So here I've got, if I'm naming the CH3 as a piece, that's not methane. Methane is the full molecule. As a piece, it's a methyl piece. Some traditions of English say methyl. Either way is fine. Methyl, ethyl, propyl, butyl. pentyl, hexyl, heptyl, oxyl. What are my substituents? Well, I've got two CH3s here, right? Just because I didn't draw the H's doesn't mean they're not there. So my substituents are methyls. I've got two of them, two methyl groups. In the next two steps, I need to put prefixes in front of my substituents and then place them. So what do I mean prefixes? So here, it depends how many I have. If I have two methyls, I need to talk about dimethyl. If I have three, I talk about trimethyl. If I have four, I talk about tetra. These are Greek roots, not Latin. So our prefixes come from Greek roots, di, tri, tetra, penta, hexa. Probably not going to use these bigger numbers quite so much, but di and tri are pretty common. Mono would be the single, but we very rarely use that. It's usually optional, but that's what it means. Then we need to place the substituents, which is simply just saying where they are. So in this case, I've got two methyls, so it's a dimethyl heptane. But I need to say where those substituents are. Here, my substituents are on 3 and 4. So it's 3, 4 dash dimethyl heptane. Quick syntax note here. We're going to use a comma to separate two numbers. So here to separate 3 from 4, comma. That's where a comma goes. I use hyphens to separate a number from a word. So hyphens between numbers and words. How do I separate words? I typically don't. So there's not going to be very many spaces between words. In a little while, in a few weeks, we'll get to some functional groups that require spaces between words. But for now, you should not have any spaces when you're just naming alkanes. Again, one of the really powerful things about naming molecules is that this should be unambiguous. There is only one 3,4-dimethyl heptane. I might be able to draw it in many different ways or show it in fancy ball and stick format or 3D or 2D, whatever. But across all those representations, they should all be this. This is an unambiguous name. It cannot give me more than one result. Okay, let's do one more. Name that molecule. First thing we're going to do is look for the longest carbon chain. So we'll try a couple. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. All of these are the same, right? So it looks like it's going to be 6. So the longest chain is a hexane this time. So it's something, 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 hexane. Okay. Then we need to number the chains to put the branching as early as possible. So if I start left to right, 1, 2, 3, the first branch is on carbon 3. If I start right to left, and again I could start from any of these carbons, 1, 2, the first branch is on carbon 2. Okay, so that's my numbering system then. 1, 2, 3, 4, 5, 6. Name my substituents. What substituents do I have? Well, I've got 2 methyls, abbreviated Me, and I've got 1 ethyl, 2-carbon unit, abbreviated ET. Okay, so prefixes, I'm going to have a dimethyl because I've got 2 of them, and I've got the ethyl there. So now we need to put it all together. So this is where we end up. 4-ethyl 2,2-dimethyl hexane. Again, let me point out that hyphens separate numbers from words and commas separate numbers. That's one thing to point out. Something else to point out. Notice that if I have a dimethyl, I had better have 2 numbers in front of the di. If I have tri, I had better have 3 numbers in front of the tri, and so forth. It does not matter that they are on the same number. Right? So I can't say just 2-dimethyl with the assumption that, well, there's only one number there. Always have the number of numbers match the prefix. So if there's 2 methyls here, you have to say 2, 2 dimethyl hexane. The final thing, and frankly the thing I worry and care the least about, why is ethyl in front of methyl? Because of the alphabet. E is bigger, E comes before M, and so ethyl comes before methyl, even with the dimethyl. It's pretty dumb, but that's how it is. I wouldn't stress out too much about that. Much more important to follow the rest of this stuff to get the numbering correct and to get the prefixes and places correct. Language development. So we need to know some common names, some shorthand names for substituents. We can name these as pieces of the bigger whole, but remember, this doesn't get us out of going through the steps we just laid out, name the longest chain, and so forth. But as pieces, we talked about methyl and ethyl and their abbreviations. If I have a 3-carbon piece, there's actually 2 flavors of that. There's one where the 3 carbons are in a row, in a line. We call that N-propyl, abbreviated NPR. But we can also imagine attaching it to the middle of these 3 carbons, right, making a little fork there. So these little forks are isopropyl. Notice that there's no hyphen here for ancient name reasons. I don't know why, but isopropyl is abbreviated IPR. So isopropyl alcohol, for instance. Okay. There is an isobutyl, isopentyl, etc. Iso typically means there's this little 2-carbon fork at the end of a chain. There are a few butyls. There's 4 butyls: N-butyl, sec-butyl, isobutyl, and tert-butyl. I really only care about these 2. N-butyl is the long chain. Again, N denotes that it's just a linear chain. And then this one, tert-butyl. Sorry, this wavy line just means it's attached to something that I don't really care about. So a tert-butyl group has a carbon with 3 methyl groups attached to it. This is a tert-butyl group, abbreviated TBU. We talk about this as being very bulky in space. So you should know these shorthand abbreviations, and then the nicknames for these things, we'll use them quite a bit. One more shorthand thing to use, again, language development: primary, secondary, tertiary, and quaternary carbons. So this basically looks at how many other carbons the carbon in question is bound to. So when I talk about a primary carbon is typically a CH3. A primary carbon is bound to 1 other carbon. So this would be primary, and everything on the ends here would be primary carbon. Secondary carbon, usually a CH2, secondary carbon bound to 2 other carbons. So this would be secondary, that would be, and this one. Tertiary carbon bound to 3 other carbons, often has a CH. This is tertiary. And finally, a quaternary carbon, quaternary, I don't know how to pronounce it. I go back and forth depending on the day, how I'm feeling, you know. Anyways, 4 bonds to carbon. This is my quat carbon. So you should also be able to communicate not just with these things, but with that. And again, this is a good way to point out, just because I have this quaternary carbon on the end doesn't mean that tert-butyl should show up in the name. In this case, it shouldn't, because remember, our first thing we did was go find the longest carbon chain. And the longest carbon chain breaks up that tert-butyl group.